Hey, I bet you this is what you've been waiting for. What's the use of all this stuff that we've been doing? Well, let's put it all to use right here now and do some problem solving. Have a look. You've seen this sort of problem before. How big an area can you enclose with a certain length of wire? And that's going to give us a quadratic. What about over here? What's the surface area or the size of a box? They have a particular surface area, that sort of thing. And down here, I mentioned this before, when you're looking at manufacturing industry and economics, there's quite often a mathematical formula that describes perhaps a revenue that that company might make from making an X number of jackets and stuff. So this is the useful time, not just the mathematics, but using it to solve problems. So let's have a look at how we go about doing that. And here I've got Huddy's little system of problem solving, if you like, some steps that you might follow. And the first step up here, carefully read the question, note all the given information, underlining key points is of value, so you don't leave anything out. I'm going to show you how to do that in a minute. Draw a clearly labelled diagram if one isn't given, and make sure you use all the given information. That's important. Okay, all the given information. If you get stuck, often you can go back to the statement and you can find something you haven't used. Introduce a pronumeral. We're going to use algebra. Algebra is a fantastic problem solving tool. Introduce a letter, doesn't have to be X, but we introduce a letter for the quantity to be found, then track it through, summarising all the given information, make an equation, use an equation, a mathematical sentence. And then if you make sure all points have been included, you should be able to solve that equation. So, after all those years of algebra, you can see now, you can use it in problem solving in a practical way. Now you should check the validity, the truth, or whether the answer is valid or relevant to the problem. So, for example, you can't have negative lengths, can you? So, in the formula that you might use to solve the problem, if you get a negative answer, like in a quadratic you could have a positive and negative answer, the negative won't be relevant if it's meant to be a length. Mostly negative numbers or negative answers won't be relevant in problem solving in our everyday world. We don't have a lot of negatives floating around. Okay, so that sort of thing. And maybe there might be no solution to the problem. It might not be possible to conform with the initial conditions or whatever to find a particular expression or length. Okay, so think about that. We just did that with the discriminant. If the discriminant is less than naught, if it's negative, you can't find the square root of it, there won't be a solution. That means the problem doesn't have a real answer. You can't do it. Okay, state the solution in words, and this is important. You might introduce X, algebra land, but that's not what people want to know about. That's a tool, that's a mathematical tool. They want to know, in terms of the question that was asked, what's the answer? So unpack it all. Don't say X equals, say the length required equals, or something like that, in the context of the question, because this is mathematics alive now, relevant to the real world, and we need to explain our answers like that, not stay in math land. Let's get started and see what you think. And so here's the first problem here. Okay, a rectangle has length 3 centimetres longer than its width. Okay, hang on, we better do this. 3 centimetres longer than its width. Its area is 42 centimetres squared. Find its width. Okay, here we go. Come across to the right here. Carefully read it. Yes, we've done that. Underlining points. Draw a clearly labelled diagram. Okay, let's do this next. Well, here they've done it over here. Here's a rectangle, and its length is 3 centimetres longer than its width. So let the width be X over here. So there it is. Length is X plus 3. You don't have to use X. You could use W and W plus 3 if you like, making it more relevant to the words. I would tend to put on the diagram something like this. so that all the information is contained in that diagram so you don't forget anything. Now, introduce a pronumeral, we've done that. Summarise the given information using occasion, make sure all points will be included. Okay, so they've given us something here, the area. So let's work out an area formula over here. X times x plus 3, length times width is 42, and we have a quadratic. So we've done it. We now are down to this point solving the equation. Okay, so we're going to use the formula for the roots of a quadratic. And there it is there. We might just put the values in. A is 1. B is 3, C is neg 42. Okay, so we get 177 in there, and we've got two answers, neg 3, take root 177 on 2, so it's negative, so we reject that, because here x must be greater than 0, it must be a positive length. Okay, so this is approximately 5.152, and we can use this sign or this sign, and we'd usually say round this off to 3 significant figures, so we wouldn't use that. It'd be 5.15 centimetres to 3 significant figures, stating what level of accuracy we've chosen to use. Okay, so check the validity. Yes, we remove the negative one and state the solution. Yes, we did that. You get the idea. It's a powerful tool now if we apply it properly. Let's have a look and have a go at some of these. There's our box that we had in the first screen there. So here are some problems from the Hayes and Harris screen clippings there. So have a look at their book. Alright, have a go at these. You wouldn't have diagrams for number problems as such. Okay, but the other problems where you have real life sort of situations, draw a diagram down here. You'll need a diagram. Alright, have a go at these. I think you should go through all of them. There's question 1 to 4. The answers are coming up down below. And let's just then go to 5. Okay, so you can see the rest of 5. Alright, pause it, have a go, and check your answers one by moving forward through the video, and here are the answers. Okay, question 1 to 5 there. Okay, hope you did okay with that. Let's move on and develop it a bit more and see what you think, because we're in a practical situation now, so this is good. Let's have a look now at the next few here. Alright, so here we are. Is it possible, oh this is interesting, is it possible to bend a 12 centimetre length of wire to form the legs, I don't like that, legs or a right angle triangle, I'd rather just say the sides, with an area of 20 square centimetres? We've underlined information, let's draw the diagram. So a piece of wire 12 centimetres, I'll put that in there, becomes this thing here with an area of 20. Okay, so we've got all the information there. Introduce a pronumeral for the quantity to be found. Alright, so we could introduce the altitude of the triangle being x, and the other side you wouldn't introduce another pronumeral, you'd use 12 take x. Okay, trying to keep it just to one letter or pronumeral. Have we used everything? Yep. Now we can write an equation. We've summarised it. Now we want to summarise it with an equation. So the area is a half base times height, and that has to equal 20. Have we got everything in there? Yes. Use all the given info. Okay, all of it. That's important. Okay, so if we now solve this equation, multiply both sides by 2, remove that half, it becomes x by 12, take x is 40, then expanding this, 12x, take x squared, and move the 40 across, take 40 equals 0. Because most people don't like negative x squared, let's multiply through by neg 1, that becomes x squared, take 12x plus 40 equals 0. and then using the formula for the roots of a quadratic. Remember this? Okay, very powerful little tool, this one. Always can solve any quadratic equation for you. Okay, as the square root of -16 comes out there. When you put in, let's just put the numbers in. A is 1, B is -12, C is 40. And there is no solution to that, no real solution. Okay, remember that's complex number stuff there, to find the square root of a negative. So there are only imaginary solutions, indicating it's impossible to bend that and to form a right angle triangle with an area of 20. So we've done it. We'll come over here, solve the equation, check the validity of the solution. Yeah, well, we can't find a solution and state the solution. No, it's not possible. So there's the answer to that question. That's interesting, isn't it? That you can actually use mathematics to see whether something's possible. That's a powerful idea there. Okay, come down and try some. Here's another one along the same lines in question 6. So follow through a systematic process, underline all the information, try and draw a diagram, introduce a pronumeral, get the idea going there. Okay, I'll have a go at these three. Need to do all of these to build up the skill level now. And let's come down then and have a look at 9. There's 9. Okay, you need to draw a diagram there for number 9. And let's look at the solutions to that little group then. Okay, 6, 8, 9, 7 is something of the answers contained within the problem. See if you can prove it. Alright, how are you going? Getting some skills together there? Let's have a look at the last example and the last few problems now. Okay, remember our steps over here. I'm writing them down every time. Might be worth making a note of them. A wall is 12 metres long and it's timber panelled using vertical sheets of panel of equal width sheets. If the sheets had been 0.2 metres wider, 2 less sheets would have been required. What is the width of the timber panelling? Okay, let's draw a diagram. We've got this 12 metres long, and therefore what are we going to do? We're going to put sheets in there like this. Okay, so let the sheets be X metres wide, because they said what is the width of the timber panelling. Now, what is the number of sheets there for? Because it says 2 less, we've got to somehow work this in. So the number of sheets will be, how many times does X go into 12? That's the number of sheets. Okay. Now if the sheets were 0.2 metres wider, so that's X plus 0.2, you could put that in, or X plus a fifth, then you'd need 2 less sheets. So the number of sheets would be 12 over X take 2. So that incorporates all the given information. So what that means is, if you have the sheets now of that width, here it is over here, you would need this many to make 12 metres. So this many lots of that width must come to 12. A hard problem now, this one, a little bit tricky, but working around trying to incorporate, where are we? Down here somewhere. This is hard now. Trying to get an equation where you can incorporate the given information, 2 less sheets if they are 0.2 metres wider. Okay. Alright, and we've got a denominator in here, so we multiply everything through by X. Oh, well, they haven't done that first, so I suppose we better do it their way. I would have multiplied through by the denominator, but here we are. So it's X by 12 over X is 12. X by -2 is -2X. A fifth by this is 12 over 5X. A fifth by this is -2 fifths equals 12. I think I would have put probably 0.2 in there, instead of a fifth. Okay, and then what have we got here? Let's have a look and subtract 12 from both sides. So we're left with this expression equals 0, and then multiplying through by the denominator, they've left it down here, so 5x becomes negative 10x squared, that cancels, be 12, 5x here, gives us negative 2x equals 0. Okay, and then they've multiplied through by negative 1, here's all over here. Divide each time by, oh no, they've divided by negative 2, yep, so they've actually divided through. I was going to multiply through by negative 1 to get rid of the negative, but they've divided by negative 2 to make this a positive 5x squared. Oh, then they've factorised it, because it looks like an easy one. Or you could use the formula in there. Okay, depends on how well you've mastered factorisation. So negative 6 over 5 or 1, but x is equal to 0, so each sheet has to be 1 metre wide. X is greater than 0, sorry there. X must be a positive. So solving the equation was pretty hard as well. Both these steps were hard. And then checking the validity, discard the negative 1, and then state the answer. So there are some challenging ones like this where it's quite hard to get the information into an equation with all this language up here, come up here. So, 2 less sheets, how would you work that in? Okay, so that's an interesting problem. Let's see how you go on some of the harder ones now, and we've just got a few left here. Okay, so these are the more challenging ones, and some here to do with speed. So just remember, if you're looking at speed or velocity type problems, you need some sort of formula, I suppose. So the speed is the distance divided by the time, something like that. Watching your units, kilometres per hour perhaps. B, speed is distance divided by time, and you might like to rearrange that because it says in 20 minutes less, so you might have to work with time, not speed, as the subject of the formula, that sort of thing. So these first three are all that sort of problem with speed and time, and the last one is a little bit different. So don't forget this relationship up here. All right, have a go, and let's look at the answers now, and just come down here, and they are our answers. Okay, what do you think? We're going to be doing quite a bit more of this later on as we build up more skills with quadratics. But for now, it's cheers from me. I'll catch you a bit later on.